This is Geometry Lesson 7.3, Rotations. So a rotation is a fancy way to say turn. A rotation can be any number of degrees. We can turn it a little bit, like 1, 2, 3 degrees, a lot of bit, like 200 degrees. We're going to focus on our quarter turns in this section. So 90, 180, and 270 would be a 1/4 turn, a half turn, a 3/4 turn. So turning counterclockwise would be turning this direction. And then turning clockwise would be turning this direction. We usually label geometry rotations in terms of counterclockwise rotation, but I have them on here as both ways. So going 90 degrees counterclockwise, so a 1/4 turn to the left, is the same as going 3/4 turn clockwise or to the right. 180-degree rotation doesn't really make a difference, because if you're going halfway to the left or halfway to the right, you still end up halfway in the end. And just like a 90 counterclockwise and a 270 clockwise is the same, a 270 counterclockwise and a 90 clockwise is the same. So for the way that these rules work, when you have your coordinates of your original figure and you want to do a 90-degree counterclockwise rotation, you would take those coordinates and flip their positions. So the number in the front, or the x position, would go to the back in the coordinates of the image, and the number in the back would go to the front. So let's get the coordinates of this triangle, and then I can hopefully show you what I mean. So A would be 1 and 1. B is 1 to the right and 6 up, so that's 1, 6. C is 5 to the right and 4 up, so 5, 4. So when we do our 90-degree counterclockwise rotation, the rule tells us that we flip the coordinates. So any number in the x position now goes to the y position, and any number in the y position now goes to the x position. But we also want to add negatives to the new x that came from the old y. So let's try graphing these points and see what happens. So A is -1, 1, which is 1 left, 1 up, and we'll mark it A prime there. B is -6, 1, that is 6 to the left and 1 up. And C is -4, 5, that is 4 to the left and 5 up. So we can see that the original triangle, graphed in black, C kind of points to the right, but this new triangle, C kind of points up. So that whole triangle turned a 1/4 turn. So now we'll do a 180-degree rotation. We're going to think about these original points again, and we're going to change those points so that both the x's and the y's turn negative. So -1, -1, -1, -6, -5, -4. All of those original coordinates turning negative. -1, 1 means 1 left, 1 down. And I'll put a little 2 there. B is -1, -6. That's 1 left, 6 down. And C is -5, -4. That's 5 left and 4 down. So if we connect A to B, B to C, and C back to A, again, there's another 1/4 turn. We started pointing to the right, and then we pointed up, and now we're pointing to the left. Our final rotation is going to be a 270-degree counterclockwise rotation. I'm going to look at these original points again over here, and to perform this rotation, we're going to flip the points, the x going to the back and the y going to the front, just like we did in the 90-degree counterclockwise rotation, but the negative is going to go on the second value now instead of the first one. So all of the x's in this column are now going to go to the y's in this column. So I got 1, 1, and 5. And all of the y's in this column are now going to go to the x's in this column, 1, 6, 4. And we'll add a negative on all of the coordinates in the y position. 1, -1 means 1 right, 1 down. So here's my third A value. 6, -1 means 6 right, 1 down. And 4, -5 means 4 right, 5 down. So 4 to the right and 5 down. We connect A to B, B to C, C to D. And now we can see all of our figures, our original image, as well as our 3 rotations, our 90-degree turn, our 180-degree turn, and our 270-degree turn. That is it for rotations. You should be able to continue on to the exercises. Please let me know if you have any questions.